Hi scholars, so today we're completing Module 4, Lesson 11, so let's start with our learning intention. Thoughtful mathematicians demonstrate the possible whole number side lengths of rectangles with areas of 24, 36, 48, or 72 square units using the associative property. So what that really means is that we're going to prove that different rectangles can have the same area because of their side lengths. And that really has to do with the factors, and I'll explain. So the associative property means that changing the grouping of 3 or more factors does not change the product. So for example, 5 times 7 times 3, if I do 5 times 7 first and then multiply that by 3, or do 7 times 3 first and then multiply that answer by 5, I still get the same answer. So 105 has these factors changing which group or which numbers I multiply first, right? Multiplying the 7 times 3 or the 5 times the 7 first doesn't change my final answer. And the commutative property means that changing the order of the factors also does not change my product. So with multiplication, really the order and the grouping does not matter because you're still going to end up with the same answer. And that's what we're going to use today to prove that different rectangles can have the same area regardless of the factor. So let's start with this one. Write an expression to show how to find the area of a rectangle with the side lengths 3 and 12. And so an expression is just an equation without the answer, right? So what would our expression be for this rectangle? Go ahead and take some think time. Right, so the expression would be 3 times 12 because to find the area, I multiply the length times the width, 3 times 12. So our expression would be 3 times 12. So now look at this new expression that I've written here. Why is this expression equal to this one up here? So in order to figure this out, I want you to go ahead and solve what is 3 times 12, and then think about, well, how is that equal to 3 times 2 times 6 with the parentheses around the 2 and the 6. So go ahead and pause the video now and think about this, and then when you're ready, press play to go over the answers to 3 times 12 and why it's equal to 3 times 2 times 6. All right, if you're watching now, that means you've already solved 3 times 12 and you've already thought about why this expression here is equal to the answer to 3 times 12. If you haven't already, please pause now and do so because I'm going to go over the answer. So 3 times 12 is 36. This rectangle has an area of 36 square units. Now, why is 36 or 3 times 12 equal to 3 times 2 times 6? Well, that's because the 12 was rewritten as 2 times 6. Instead of having 3 times 12, I now have 3 times 2 times 6. And this is because of the associative property, because these groupings will still give me 36 regardless of what order I write them in. So let's write the same expression with the parentheses in a different place. So rewrite the same expression and just switch the parentheses. What would that new expression be? So that new expression would be 3 times 2 times 6, except I would have the parentheses around the 3 and the 2. So 3 times 2 times 6. So now I want you to solve the 3 times 2 and write the new expression. So after we solve 3 times 2, what would our new expression be once we solved what's inside the parentheses in this expression here, 3 times 2 times 6? So our new expression would be 6 times 6, because 3 times 2 is 6. And if we multiply that by the other 6, that makes 6 times 6. So that's our new expression. So what new side lengths have we just created for another rectangle that also has an area of 36 square units simply by changing the factors here, right? We went from 3 times 12 to 3 times 2 times 6, right? Because 2 times 6 is 12. and then we move the parentheses, so change the order. So now we have 3 times 2 first instead of 2 times 6 first. And they gave us 6 times 6. So what are our new side lengths that would also have an area of 36 square units? Six and 6. So we can have another rectangle. Well, in this case, it would really be a square because the side lengths are the same. That's 6 by 6, and the area would still be 36 square units. So let's continue with this idea of using the associative property. So let's look back at that same expression we just had, 3 times 2 times 6 with the parentheses around the 3 and the 2. Use the commutative property and switch the order of the factors in the parentheses. So switch those two numbers in the parentheses. What would our new expression be? Right, it would be 2 times 3 times 6. So my answer is still going to be 36. I'm just switching around the order. Will you be able to find new side lengths by moving the parentheses? So if we were to move the parentheses in this expression here, would that give us a new, sorry about that, a new side length? Right, so if I do this now, I just switch move the parentheses, 2 times 3 times 6. Would this give us a new side length? So it actually would, because we would now have 2 times 18, because 3 times 6 is 18. So we now have another rectangle, 2 times 18, and it's still going to have the same area of 36 square units. So far we have 3 shapes that have an area of 36 square units. Our original 3 times 12, 6 by 6, and 2 by 18. So look at this new expression here. Why is this new expression equal to the very first one that we started with, 3 times 12? Why is it the same exact thing? Think about the associative property. So all I did was change the 12 to be 3 times 4. So instead of 3 times 12, I now have 3 times 3 times 4. So write this expression on your board or wherever you're writing with the parentheses in a different place. What would our new expression be if we move the parentheses? All right, so I would now have 3 times 3 in parentheses times 4. So let's solve 3 times 3 and write this new expression. If we solve the 3 times 3 and keep the 4, what would this new expression be now? Right, so you should have found 9 times 4. So that is yet another rectangle that also has an area of 36 square units. So with just the area of 36 square units, we were able to find 4 different rectangles that added up, or not multiplied, into the same answer. So that means that 36 has multiple factors. We did, let me list that over here. We did 3 times 12, 2 times 18, 9 times 4, and there was one more that I'm forgetting, and 6 times 6. 6 times 6. So all of these factors add a multiply to 36. So they're all factors of 36, because when I multiply them, I get an answer of 36, or a product of 36. So that's what we meant by in our learning intention, that we're going to use rectangles that have specific areas to see different side lengths that still amount to the same area. So let's look at a different one. The rectangles below have the same area. Move the parentheses to find the unknown side lengths, then solve. So here I already know that 9 times 4 is 36, because 4 times 9 is 36. So this is 36 square centimeters. I have another rectangle here, and I know it's going to be the same area, but I don't know the side lengths. And that's what I'm going to try and figure out by moving the parentheses. So 4 times 9 is the same as 4 times 3 times 9. So like it says in the problem, in the directions, I'm going to move the parentheses. So I now have 4 times 3 first times 3. Well, 4 times 3 is 3, 6, 9, 12. So that's 4 times 3 is 12. And I keep the 3, right? It's outside of the parentheses. 12 times 3. And I already know it's going to have the same area, so the area is 36. So my side lengths are 12 and 3. So try this last one, doing the same thing I just did. We're moving the parentheses to find the new side lengths. So go ahead, pause now, and try this one. You can always rewind if you're not sure what I just did or you need to look at it one more time. And then press play when you're ready to check your work. All right, welcome back. So you should have already solved. If you haven't already, please pause again so that you don't see the answer before you've solved. All right, so I have the same rectangle that we started with, right? And this new rectangle. So I know this area is going to be 36 because it says the area is the same. What I don't know is the side lengths. Well, I have 4 times 9 can be 2 times 2 times 9 because 4 is the same thing as 2 times 2. The parentheses is around the 2 times 2, so I'm going to move our parentheses like it says to. So I keep the 2, first 2, and now I want 2 times 9 to combine. So 2 times 9 is 18, right? So my side lengths are 2 and 18, and I know that the area is going to be 36 because it says so in the directions. So in your problem set, you're going to have similar problems where you're going to have rectangles that have the same area, and you're going to need to find the missing side length or side lengths. As always, reach out to me on Schoology or Google Hangouts if you have any questions, and thank you so much for watching.